Welcome to our deep dive into the world of atoms. Today we're exploring the concept of mass number, a fundamental idea in chemistry and physics. Whether you're a student, a science enthusiast, or just curious about how the universe works, understanding mass number is essential. It helps explain why elements behave the way they do and how scientists identify different forms of the same element. Let's start by breaking down what mass number actually means and why it's so important in the study of matter. Before we get into mass number, let's quickly review what atoms are. Atoms are the basic units of matter making up everything around us. Each atom consists of a nucleus at its center, surrounded by a cloud of electrons. The nucleus itself contains two types of particles, protons and neutrons. These tiny particles are crucial for understanding mass number, so keep them in mind as we move forward. Let's focus on the nucleus for a moment. Protons are positively charged particles while neutrons have no charge at all. Both have nearly the same mass and together they account for almost all of an atom's mass. The number of protons in an atom determines what element it is, but the number of neutrons can vary. This variation is key to understanding mass number. Now let's define mass number. The mass number of an atom is the total number of protons and neutrons in its nucleus. It's a simple sum, just add the number of protons and neutrons together. This number is always a whole number and is unique for each isotope of an element. Mass number is different from atomic number, which only counts protons. It's easy to confuse atomic number and mass number, but they're not the same. The atomic number tells you how many protons are in an atom, which defines the element. The mass number, on the other hand, tells you the total number of protons and neutrons. For example, carbon always has 6 protons, but its mass number can be 12 or 14 depending on the number of neutrons. Calculating mass number is straightforward. If you know the number of protons and neutrons in an atom, simply add them together. For instance, if an atom has 8 protons and 8 neutrons, its mass number is 16. This calculation is fundamental in chemistry, especially when identifying isotopes or understanding nuclear reactions. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. This means they have different mass numbers. For example, hydrogen has 3 common isotopes, protium, deuterium, and tritium, with mass numbers 1, 2, and 3 respectively. Isotopes can have different physical properties even though they're the same element. Scientists often write elements using a special notation that includes the mass number. For example, carbon-12 is written as 12C, where 12 is the mass number. This helps quickly identify which isotope of an element is being discussed. The notation is widely used in textbooks, research papers, and laboratory settings. Mass number is more than just a number, it's crucial for understanding the properties of atoms and elements. It affects atomic mass, stability, and how atoms interact in chemical reactions. Knowing the mass number helps scientists predict behavior, identify substances, and even date ancient artifacts using isotopic analysis. While mass number is a whole number, atomic mass is usually a decimal. That's because atomic mass is the weighted average of all the isotopes of an element based on their abundance. Mass number, however, refers to a specific isotope. This distinction is important when interpreting the periodic table or conducting experiments. On the periodic table, you'll notice that each element has an atomic number and an atomic mass. The atomic number is always a whole number, but the atomic mass is often a decimal. The mass number isn't shown directly, but you can use the atomic mass to estimate the most common isotope's mass number for each element. Let's look at carbon as an example. Carbon has 2 stable isotopes, carbon-12 and carbon-13. Carbon-12 has 6 protons and 6 neutrons, giving it a mass number of 12. Carbon-13 has 6 protons and 7 neutrons, so its mass number is 13. Both are naturally occurring and play important roles in chemistry and biology. Hydrogen is another great example. Its most common isotope, protium, has 1 proton and no neutrons, so its mass number is 1. Deuterium has 1 proton and 1 neutron, mass number 2. Tritium, which is radioactive, has 1 proton and 2 neutrons, mass number 3. These isotopes have different uses in science and industry. Some isotopes are unstable and radioactive. These isotopes have mass numbers that make their nuclei unstable, causing them to decay over time. Radioactive isotopes are used in medicine, archaeology, and energy production. Their mass numbers help scientists track and use them safely and effectively. Nuclear reactions, mass number plays a crucial role. During reactions like fission or fusion, the mass numbers of the reactants and products must be balanced. This helps scientists predict the outcomes of nuclear processes and ensures the conservation of mass and energy in these powerful reactions. Medical imaging and treatments often rely on isotopes with specific mass numbers. For example, iodine-131 is used to treat thyroid conditions, while technetium-99m is used in imaging. The mass number helps doctors and scientists select the right isotope for each application, ensuring safety and effectiveness. Archaeologists use isotopes with known mass numbers to date ancient artifacts. Carbon-14 dating, for example, relies on the mass number of carbon-14 to estimate the age of fossils and relics. This technique has revolutionized our understanding of history and prehistory. Nuclear power plants use isotopes with specific mass numbers to generate energy, and plutonium-239 are 2 common examples. Their mass numbers determine how they behave in reactors and how much energy they can produce. This knowledge is vital for safe and efficient energy generation. Stability of an atom's nucleus depends on the balance between protons and neutrons, which is reflected in the mass number. Atoms with too many or too few neutrons compared to protons can become unstable and radioactive. Understanding mass number helps scientists predict which isotopes are stable and which are not. In chemistry, mass number is used to identify isotopes and predict how atoms will react. For example, different isotopes of the same element can have slightly different chemical behaviors. This is especially important in fields like analytical chemistry and environmental science. Environmental scientists use isotopes with specific mass numbers to track pollution, study climate change, and understand natural processes. For example, oxygen and hydrogen isotopes in water can reveal information about past climates and water sources. Mass number is a key tool in these investigations. Forensic scientists use isotopes with known mass numbers to solve crimes. By analyzing the isotopic composition of evidence, they can determine its origin or track movements. This technique adds a powerful tool to the forensic toolkit, helping bring clarity to complex investigations. Space missions often analyze the mass numbers of elements found on other planets or asteroids. This helps scientists understand the composition and history of celestial bodies. By studying isotopes, researchers can learn about the processes that shaped our solar system. Biologists use isotopes with specific mass numbers to trace biological processes. For example, they can track how nutrients move through ecosystems or how drugs are metabolized in the body. This information is vital for research in medicine, agriculture, and ecology. Industries use isotopes with specific mass numbers for quality control, tracing materials, and improving processes. For example, radioactive isotopes can detect leaks in pipelines or measure the thickness of materials. Mass number ensures the right isotope is chosen for each application. Handling isotopes with different mass numbers requires strict safety protocols. Some isotopes are radioactive and can pose health risks if not managed properly. Understanding mass number helps workers and scientists follow the right procedures to protect themselves and the environment. Researchers use mass number to design experiments, interpret results, and develop new technologies. Whether in physics, chemistry, or biology, mass number is a foundational concept that supports scientific discovery and innovation. Teachers use mass number to introduce students to atomic structure and the periodic table. Understanding mass number helps students grasp more advanced topics in chemistry and physics, laying the groundwork for future learning and scientific literacy. Technological advances often rely on isotopes with specific mass numbers. From medical devices to energy production, the right isotope can make all the difference. Mass number guides the selection and use of these materials in cutting-edge technology. As science and technology progress, mass number will continue to play a vital role. From new medical treatments to sustainable energy solutions, understanding mass number will help us solve some of the world's biggest challenges and unlock new possibilities. Let's review what we've learned. Mass number is the sum of protons and neutrons in an atom's nucleus. It's different from atomic number, which only counts protons. Mass number helps identify isotopes, predict stability, and guide scientific and industrial applications. A common misconception is that mass number and atomic mass are the same. Remember, mass number is always a whole number for a specific isotope, while atomic mass is a weighted average. Keeping this difference in mind will help you avoid confusion in your studies. Let's try a practice problem. If an atom has 11 protons and 12 neutrons, what is its mass number? Simply add the two numbers. 11 plus 12 equals 23, so the mass number is 23. This method works for any atom as long as you know the number of protons and neutrons. Here, another one. An atom has 17 protons and 18 neutrons. What's the mass number? Add them together. 17 plus 18 equals 35. The mass number is 35. Practicing these problems will help you master the concept and apply it in real situations. Let's do one more. If an atom has 2 protons and 2 neutrons, what is its mass number? Add them. 2 plus 2 equals 4. The mass number is 4. This simple calculation is the foundation for understanding isotopes and atomic structure. You might not realize it, but mass number affects your everyday life. From the smoke detectors in your home to the medical tests you take, isotopes with specific mass numbers are at work behind the scenes, keeping you safe and healthy. Innovations in science and technology often depend on understanding mass number. From developing new materials to advancing medical treatments, mass number is a key factor in research and development across many fields. On a cosmic scale, mass number helps astronomers understand the composition of stars and galaxies. By analyzing the mass numbers of elements in space, scientists can learn about the origins and evolution of the universe. Every atom in your body has a mass number. The food you eat, the air you breathe, and the water you drink all contain atoms with specific mass numbers. This invisible world shapes your health, your environment, and your future. To sum up, mass number is a simple yet powerful concept. It's the total number of protons and neutrons in an atom's nucleus, and it plays a crucial role in science, technology, and everyday life. Mastering this concept opens the door to a deeper understanding of the world around you. If you're interested in learning more, there are many resources available. Textbooks, online courses, and science documentaries all offer deeper dives into atomic structure and mass number. Exploring these topics can spark your curiosity and inspire future discoveries. You might see mass number mentioned in the news, especially in stories about nuclear energy, medical breakthroughs, or space exploration. Understanding this concept will help you make sense of these stories and appreciate the science behind the headlines. Curiosity drives scientific discovery, and mass number is a perfect example of how simple questions can lead to profound insights. By asking what makes one atom different from another, scientists unlocked the secrets of the atomic nucleus and changed our understanding of matter forever. As we wrap up, remember that mass number is more than just a number, it's a window into the heart of the atom. Whether you're studying for a test or just exploring the wonders of science, understanding mass number will enrich your knowledge and appreciation of the universe. Thank you for joining us on this journey through the world of mass number. We hope you've gained a clearer understanding of this important concept and how it shapes the world around us. Stay curious, keep learning, and remember, the secrets of the universe are often hidden in the smallest details.